We pretty much built the most valuable data collection engine for real world driving data.
For how much money?
$150 million.
Every dollar you spend is another dollar bonus to your salary.
You're bonusing people to rack up token bills on Cloco?
Yes, correct.
Crazy. From a commercialization perspective, I should go and find someone that could be better than me. I'm a data holder, so I never can get enough.
You're a data hoarder.
Yeah.
What is a data hoarder? Last two questions. Who named the model badass? Welcome back to another episode of Invested. I am thrilled to have with me here Zach Greenberger, CEO of Nexar, and Eran Shir, founder and chairman and former CEO of Nexar, but still very active at the company. And the reason we're getting together today is the world of AI is changing right in front of our eyes. And I think the kind of ringing of the bell on that was an announcement by Uber over the last 48 hours, where all of a sudden they said, hey, wait a minute. We've got this giant fleet of cars, kind of. They're not their employees. They're not their cars. They're other people's cars. And how come they're not collecting data like real world data, like Tesla has been? And Tesla's had that massive advantage. In fact, what you'll hear from the Nexar team here is this data has been collected by two companies, Tesla and Nexar. And we're at this interesting transition point in the world of artificial intelligence from synthetic data and scraping all the digital data out there to trying to figure out how do we ingest all the real world data out there. And that's why I'm thrilled to have Zach and Eran with me. Welcome. Okay, so Zach, why don't you kick us off? Tell you wrote a LinkedIn post a couple of days ago about Uber's announcement. Tell us what the Uber announcement was and what your reaction was.
Sure. Well, Uber announced that they are going to start putting sensors on vehicles to collect real world data so they can train autonomous vehicles or give the data to their autonomous vehicle partners. And our first reaction was excited because it's been something that we've been telling the industry for quite some time is necessary in order to get to the final stages of autonomy. And while the industry has acknowledged that it's necessary, there's a level of maturation the industry needed to get to be ready to start ingesting real world data. So I think we felt super excited that it was a moment in time where the rest of the industry is now following suit and meeting us where we are, where, you know, the assets that we have that we are ready to start continuing to deploy to our partners today is going to become of material importance in how they actually get to full autonomy.
Eran, for disclosure purposes, an entrepreneur residence at Aleph, which is where Nexar got cooked up. I think it's important to tell the genesis story of how you got started and the insights you had when you got started.
So basically, this is like 2014 already. Oh my God, I'm old. But the point was...
We are old.
Yeah, you don't look old, man. And the point was AI, then called deep learning, is going to move from the cloud to the edge. That was one key insight. GPUs are coming to the edge. What kind of problems can we solve with that? Driving and safety on the road is probably the most important. Autonomy is one of the most important. And we understood that in order to do that, you have to collect a lot of data in order to train. This was... Even back then, it was obvious that in order to train models well, you have to collect a lot of data. But I think what we understood very early on is that the only way to collect the valuable data is through crowdsourcing. Why? Because what's valuable data? It's all of those crazy edge cases, right? Like if I have a fleet of very good professional car drivers and they're driving around on the highway, nothing happens. It's like I'm driving one car, 1 hour times 20. It doesn't really help. What helps is to get all of the out of distribution stuff, all of those collisions, near collisions, Bambi's running into the road, all this kind of crazy stuff. And the only way to do that is to be there. Chris Jarvis used to say, what's the best camera? The one that you have in your pocket, right? In our case, and in collecting data, it's 100 times more important, right? You need to be there. It doesn't matter what kind of camera you have, what kind of rig, what kind of sensors you have. You just need to be there to capture, and AI will take care of the rest. And that's what we're trying to do, is to figure out how could we get to scale? How to get to hundreds of thousands of vehicles? And that was quite a journey that you and I went through over the last decade of figuring out, hitting our head in the wall. I think initially we were so naive, right? Like in some sense, we thought, okay, we're gonna, bang on the OEM's doors, tell them how great the world will be if they do it. We work with them, we'll give them software and stuff like that. And then it turned out that they're so far behind. So, shit, we have to do it ourselves. We have to go build hardware. We have to go, do sales of said hardware. It's been, quite a
At
journey.
first, you thought people were going to take their telephones and just mount them on a metallic, on a magnetic mount on the windshield, and then they melted in Las Vegas.
Yes, exactly. Yes. Then we learned the physics of the sun in August in Vegas, and we say, okay, we need to get serious.
And how many miles of data do you have?
I think something like 12 billion,
12 billion.
something like that.
How big is Tesla set?
Well, it's
We don't know, right?
we don't know, but it's significantly larger than ours because they have millions of vehicles. The interesting question, though, and this is where it gets a bit nitty gritty, is how much data per mile you manage to squeeze. And that's where I think we did some cool stuff, which is basically we engineered our entire system as one single computer. Right. So all of those hundreds of thousands of cameras out there with a little GPU and the sensor and connectivity, all that, they're actually part of the same mesh, the same kind of grid of compute. And we can go and know exactly what each of them has collected and fetch it if it's interesting. So our signal to noise ratio, which is how many important, valuable bytes per mile or paid per data upload we have, I think is actually quite up there.
And there is a metric that's pretty interesting, though, beyond Tesla, which is, Waymo just celebrated collecting 100 million miles ever, which is an incredible feat. We do double that on a per month basis. So it's a pretty significant data collection.
So that's an important point. So cumulatively, Waymo celebrated 100 million miles. You just celebrated 100 million miles, 200 million miles a month, or 100 million miles every 15 days. Like, how is that possible? Like, with all the money Google has,
Yeah.
and
The crowdsourcing at scale. So 350,000 connected cameras traveling around at any given time, that have been purpose built for unique data collection. Everything from the AI models at the edge that are collecting interesting things all the way to the orchestration methodology that is offloading data efficiently so we can collect the stuff that's interesting.
what's the cost per mile for you?
Well, actually, we make money on a per mile basis, and that's a
You
critical.
make money for other people who collect your data.
Yes.
Yeah.
Yes. That's a critical point that allowed us to as a frugal kind of startup from Tel Aviv, we had to figure out a different way than how the industry went. The industry went as, okay, we're gonna raise a bunch of money, a bunch like billions. We're gonna build a bunch of cars with lots of sophisticated sensors and lidars and cameras and all this kind of stuff, and we're gonna do this fleet with expensive people and drivers in there. Like we're gonna pay, $50 an hour to do this thing. We had no chance in that. We went the other way. We're gonna actually charge people on the benefit of buying our cameras, installing them, getting all the goodies we're gonna give them, and supporting them and helping them stay safe on the road, which is very important. But in essence, we actually get paid on a per mile basis, which allowed us to scale.
And what does it cost Google per mile? Do we know, Waymo?
Probably between $30 and $50 per mile.
Per mile. So you get paid
A few
pennies per mile, and they pay $30 to $50.
Yeah.
Based on the business model means that we pretty much built the most valuable data collection engine for real world driving data
For how much money?
for $150 million.
$450 million.
Yeah.
When we started the conversation, you mentioned that Uber's now woken up and said, okay, we got to get real world data. Why all of a sudden? What's changing that caused them to do this?
I think what's changing is that the rideshare companies recognize that as of right now, there's two ways that they can provide value to autonomous vehicle companies. It's through demand generation or fleet management. And I think when you look at the success of companies like Waymo, the reality is that they actually can do it themselves to the extent that they want to. So, really the only way to get into the value chain is to enable developers with tools, data, or other things that are going to empower the broader, value chain of autonomous vehicles. So Uber actually is in a great position to offer data to their partners. The question is can they offer enough? And we have a significant head start on that.
I think more than just a head start, there's still, I think the penny didn't drop there fully.
What does that mean?
If you look at what they published is they're starting with a single car, a Hyundai one car with this fancy rig of cameras and sensors on it, right? And they are talking about potentially scaling it to 100 vehicle in sometime in the future, right? Over the next year or so. So it's still the old school kind of, we're gonna invest in this fleet to collect data. So we'll have some data assets. So we'll give our partners, they announced the deal with NVIDIA for 100,000 autonomous vehicles at some point in the future. So they need some quid pro quo with their partners and stuff. But I still think, like, if I were Dara, I would go a totally different route. I would say, shit, I have access to millions of vehicles. I'm going to produce millions of these cameras that are just, great for data collection. And I'm going to go and convince my drivers, even maybe, give them benefits and perks and stuff to install not 100, not even 100,000, like getting to that's the benefit. And I don't see them doing it yet.
He's a smart guy, Dara. Why isn't
Yeah.
he doing it? I mean, you come out of Lyft. You were the chief
Yeah.
business officer of Lyft. Well, why isn't he doing it?
I think there's so at the end of the day, the model of drivers versus it's a subcontractor model, right? So there is stickiness on how you think about how drivers actually use tools in order to commission their job and data privacy and all those things. And I just generally think that historically it's an area that the rideshare companies prefer to stay arm's length away from, which creates a unique advantage, whether
So
it's
that they're not W-2 employees?
correct.
Just to give you like an illustration, they announced that one Hyundai car that they're now, we, Nexar, we have somewhere between 50 and 100,000 Uber drivers with our cameras collecting data for us, right? They're drivers.
No, they're not their drivers because they're not their
They're
employees.
not the driver. They're not, they
Bring it-
chose out of all the cameras they could choose, they chose Nexar's camera.
Right. Google or Waymo has got these fancy lidars on the top of the car.
Yeah.
Yeah. Uber's going the same way. These are not stupid people. These are very smart people.
Yep.
What do they see that you don't see?
Well, first of all, I think when it comes to autonomy, um, no, no one could kind of guess in 2014, 2015 that when the AI end-to-end playbook will work. So the play it safe playbook was put as many sensors as you can on the vehicle, build it low and slow, do, you know, invest in each and every component of its own, write lots of code for all of this kind of stuff, because you don't know when the AI kind of shift will happen.
Yeah.
So I think the only two people that believed in that way back when was Elon
Musk.
Musk, that says, no, I'm not going to go that route. I'm going to, from first principles, think about this problem. At some point, AI is going to catch up. And in the meantime, I know how to do marketing. I'm going to convince people to stay with me year after year, right? I'm going to tell them a story. And us, that we believe that, that will happen.
Yeah, I think in many ways, the vision of the company was solving the last 1% of autonomy that's most critical. So Elon had the vision, but when you think about Waymo and other AVs, you have to go from 0 to 99% autonomy and before you get to from 99 to 100. So when you're thinking about it in terms of how do you make the most impact in the shortest amount of time, you are still thinking about what is the short way to get there versus focusing on the long tail of events that's critical. So I think when you put it into that perspective, you've now fast forward 10 years, you haven't been focused on the long tail of data. And here is Nexar and Tesla who have been focused on it for the last 10 years. And it makes far more sense to look at where that asset has been mined versus trying to go deploy a ton of assets to collect it yourself.
By the way, it's a very typical Israel versus America kind of game. Like if you think of the ballistic missile defense, right? Like we built the Arrow, the Americans built THAAD, right? THAAD is way more advanced, way more fancy missile, way more expensive, and 10 years late compared to the Arrow, right? We built it scrappy, we built it the way that it could work quickly because we needed it and we didn't have as much money as the Americans. I think that's like the typical kind of evolutionary pressures.
It's a disruptive country versus building it right and
Yeah.
wholesome. And so we're at this moment in AI right now, which is has met Nexar and Tesla and not many others in this interesting place, which is over the last 4 or 5 years since the ChatGPT moment, and obviously what built up to it, the internet has been scraped dry of any piece of digital data that's out there, and they're competing on improving the models, et cetera. There isn't really fresh digital data from out there, and now you've got this discussion about real data versus synthetic data and real world AI, call it, versus just what we call AI at this point, I guess, or LLMs. How do you think about that moment that we've arrived at now? Which of you wants to take?
Yeah, I think this distinction between LLMs, VLMs, and world models is gonna be an important theme over the next few years. You, of course, know that we just brought in Jan LeCun to join the board. He's the manifestation of that rift between the great work that LLMs doing versus what the future really needs, which is world models. And we're just in the first innings of world models.
What is tell the audience what a world model is.
So a world model is a model that can actually understand reality as good as we hopefully understand reality and even better. You know, when your son plays soccer and he's standing in the
Baseball.
I'm gonna
Go with soccer.
go with soccer, sorry man.
Yeah.
And he's standing in the he's a goalie, right? And he jumps to the ball and he catches it. His mind doesn't calculate the Newton equations of motion, right? But he understands it intuitively where the ball is going to end up and he catches it. That's a world model. We have in our mind a sort of an intuitive understanding embedded in our neural net of how the world works. And that's what you're trying to recreate when you create a world model. The real understanding is that you need real world data in order to create those.
I'll jump in on this. That when we first met, Michael, I remember saying to you that when you think about the manifestation of physical AI applications and you think about what goes into it, you think about the need to mine an asset that nobody really mines today, with the exception of a few companies, and that is the ability to capture real world data in real time at scale. And I think that is actually the single greatest asset that Nexar has accumulated over the years, because that is the core input to building the real world models that can actually make the physical AI applications run, from autonomous vehicles to humanoids to delivery robots to flying cars to what, name it. They're all going to follow the same exact trajectory of what is required in order to coexist with humanity.
Does the next 100 million miles matter? Like every 15 days, you're collecting 100 million miles.
Yep.
Like you've already collected 12 billion. That means by the end of this year, you'll collect another, I'm doing the math right,
2 billion.
1.2 billion miles, right? So
Yeah.
does the next 1 billion miles actually matter?
So the way I look at it is we have such a head start on the edge cases that are critical to effectuating autonomy that it's not really the incremental miles that matter. It's the coverage and understanding of the real world around you that matters,
Which is changing.
always. So the fact that we have 350,000 cameras traveling around the world at any moment in time. And I'll give you a great example. In Manhattan, we cross every street in Manhattan 4 times a day. It means that every time there's a construction zone that pops up, every time there's a pothole, a stop sign that's down, those are
A
going.
once in a decade snowstorm like happened this week.
Exactly.
Thank God you were in Tel Aviv for it.
Thank God.
Yeah.
Those are the kinds of things that are going to be critical for autonomous vehicles, even after they're fully trained, to understand in real time so they can navigate against obstacles. So it's almost as if the last 10 years, Nexar has built up a data lake that has created this massive mode. And now every incremental mile that's driven, it's actually more important that the observation of the real world around it is more important than the more miles that it's driving. So it's a very interesting dynamic.
I'm a data holder, so I never can get enough.
You're a data hoarder.
Yeah.
What is a data hoarder?
Exactly what it is. Someone that collects 50 petabytes just for the fun of it. But the point is this: you have a distribution, right? A long tail distribution of what could happen on the road. And some events happen once every 100 miles, and some once every 1,000,000 miles, and some once every 100 million miles. Okay, and basically, what you want is to go down that distribution as much as you can, because you can never know when that once in a 100 million mile event will happen.
What are some examples of either 1 or 100 million events or odd changes that you've picked up just by driving around the cities, or important tidbits of information or surprising things, just so people have a understanding?
Okay, so how about flying cars? Not flying cars that want to fly, but flying cars that just happen to fly.
What, I don't understand what that means.
Well, if you have a collision and a car kind of comes in the right moment, it can do like a Back to the Future thing and just fly in the air, right?
That only happens in the movies.
No, we have the film. So you have that. You have people driving in the forest and meeting a gazelle, right? So that doesn't happen very often. You got events at night when it's snowing, when you hit a tree, okay? So you got all this kind of crazy stuff that's happened.
Those are the most crazy things? Nothing else?
Oh, no.
Or changes on the road?
Kangaroos.
Kangaroos?
So the one cool thing about selling those cameras is that people will buy them from all over the place.
Yeah.
Like, even if we're focused on the US, we get events from Australia and Morocco and all kinds of crazy places.
What are your strangest changes or events?
So what strikes me all the time is, little girl rolls a ball across the street, or, a car passes a stop sign from a school bus that stopped. Like, all of the things that you wouldn't really think would be something that's critical to train or experience in order to be a good driver, but just happen. And they happen every 50 million, every 100 million miles. And there are things that you can't just simply recreate with synthetic or fake scenarios.
I love the action movie scenes, right? Like, the 360s, all this kind of stuff where
This last week must have been great for you with the storm across America.
Yeah. Give you an example. A piece of cardboard, right? Falling off a truck and flying into your route, okay?
Like on your windshield, like covering your eyes on the windshield?
Covering your wind, right? We got a bunch of those, right? Like, think of what kind of coordination of events need to happen in order for such event to transpire. So all these kind of really edge cases that happen in the real world, and you want your Waymo or to actually know how to react to it in real time, and it needs to kind of be trained on it.
Doesn't NVIDIA have a model called Cosmos that does this?
Yeah,
That was an evil laugh.
yeah, that was amusing because they recently at CES, which was just a couple of weeks ago, Jensen was on stage kind of presenting Cosmos 2.0 and showcasing how well it does in kind of collisions and events, and how it's better than Google's model and stuff. And much of it was trained on our data.
Why did he need your data?
They had Cosmos 1.0 a year ago, and you can go download it, play with it, and what you'll see, and we actually build that analysis for them, is how bad it was in collisions and high dynamic events. It's actually super hard to do without Pi or without getting the data. So they understood it as good as we did. They're probably some of the most clever people on the planet, and they understood they need that long tail of events, and that's why we kind of partnered with them to help them train the real production versions of their models.
What's the equation on your shirt?
Oh, that's the equation that governs your life. It's a standard model from physics. You know how they have gift shops everywhere when you go
Yeah.
there? So I took a bunch of school students to CERN, the large,
Particle accelerator.
yeah,
Yeah.
and there was a shop there.
Yeah.
So how could I not buy the standard model on a shirt?
Zach, can you read them all?
Oh my God. By the way, this is the shorthand version of the model.
Oh, good. Perfect. I feel much better now. I feel like I'm much more complex than the model under shirt. Iran, you mentioned the Arrow missile before, was one of the developers of the navigation system on the Arrow missile many, many years ago.
Just a soldier. I wasn't.
Okay. And what's your background, Zach?
Um,
'Cause I want to spend a couple of seconds talking about the
Yeah.
transition here. Yeah.
My background's largely in commercial and supply chain. So I spent time at Tesla. I was the chief business officer at Lyft for some years. And I've always had this passion for taking new technologies that exist and figuring out how to bring them to new people. So yeah.
You have any technical background?
Nope.
There are like funds today, like called Founders Fund. And no disrespect meant to Peter Thiel and Trey Stevens. I love those guys, et cetera. But there's a notion, I think, in the market today, the founders kind of need to go all the way. Here we are 10 years into Nexar. And like you said, it was a grind, right? Against the grain. No one really understood why the hell you were a data hoarder for all those years and why this was actually important. And everyone looked at a company that was raising like 80 or $100 million and said, oh, what a piker. These people don't matter. Go to the companies that raise 400, 500, $1 billion. And then you make the decision that you need to bring on a CEO. What causes that? And what were the challenges?
Yeah, I think that the key insight for me was actually things are getting real, and I want to give Nexar the best chance it has to succeed. And that means that, from a commercialization perspective, from taking Nexar to the next level, I should bring in someone to be the CEO of the company. There was also an element of like, I need to either do that or move to the US, and I really wanted to stay in Israel. So I think it was the right time for me to go and find someone that could be better than me in those aspects of the business, and that will also give me the freedom to focus on this really AI revolution that's brewing, and allow it to really focus on taking Nexar to that next level from AI perspective.
What are some of the things you have to do when you come in as a CEO and replace the founder in the CEO seat that are maybe not obvious to other people out there?
So I think what I'm most grateful for when I started was ruthless transparency in the form of being very upfront with Iran and Bruno that the only way I was going to be successful is if I had their full support, but if I also had their full engagement. So I think what I learned was low ego, high curiosity, and also a deep appreciation for the things that have been built and perhaps the areas that we need to find deeper focus. And I think we built a really great partnership very fast because we were able to divide and conquer and complement each other on areas that, were our strengths. So even to today, I focus a lot on telling the story on how we take this very complex technology into a way that the market can really understand. And Iran and Bruno focus on what, strategic growth looks like for our technology, how to deepen our data moats, how to do all of the things that are going to be critical long term.
What was hard?
What was hard?
Yeah.
I think the hardest part was realizing that there was something very special within Nexar, but also realizing that the market timing had to be right in order for us to really become the foundational company that I believe we should be. And I feel really fortunate that, you know, we've we've pushed really hard to get our customer base and new partners to start using our products and tools, but even more importantly, that the market at the same time has started to recognize and understand the importance of data and the things that we're building.
Yeah, it's like Moses, 40 years in the desert, 10 years in the desert until the market finally.
All right, it was a fun desert, but I tell you, I'm looking at Zach doing things with wonder. Like I'm looking at him with wonder, doing things that I don't see myself doing or being able to do that have such massive impact, right? Like going and weaving in this, highly strategic deals with, with ease and finesse, right? In that respect, I think I'm very fortunate. We're very fortunate to have him and as our leader, and I think
This is so touchy-feely, so nice. It's so unusual for this podcast. It's like, no, it's very good.
we need to start mud wrestling. So light and deal. That's what.
The One of the things that you were cooking up next to our inside Aleph that I found attractive, the point you mentioned earlier, which is that the cost per mile could be net positive rather than net negative. This company has always been way ahead. And by the way, apropos the timing comment, it took a long time
Yeah.
to build this moat and then the market to kind of come around. But this company has always been ahead of the curve in trying to uniquely figure things out. So I asked you before, Zach, do you have a technical background? And you said no.
No.
But you're writing code now?
Yes. Claude code, orchestrating code.
I think this is important about
Yeah.
like how Nexar has transformed over the last 12 weeks into what are you calling it?
Agentic
Okay.
organizer.
Agentic organization.
Yeah. So I'll start with saying that Bruno and Iran are of probably the top 0.001% on the planet with agentic transformation, and I would put money on that. And the main reason being is we are small and nimble enough to try new things and really put our company in a place where we can build agentically and make sure that we're not sacrificing product integrity, but we're also increasing velocity. So what that means in terms of someone that doesn't have a technical background is the tools are now available today to be able to go build things that historically I would have needed to lean on engineers for. So I've always tried to lead from the perspective of one, I will never ask someone to do something that I'm not willing to do myself, but out of genuine curiosity that I didn't want to rely on anyone to build certain tools and applications that I needed personally. So this was me sitting down with Bruno and Iran for an hour and them both telling me, no, you're going to go suffer and you're going to figure out how to do it yourself. And I did. And I think that us leading from the front, and by the way, that means that Iran and Bruno, even as co-founders and leaders of the company, are still producing and deploying more code than mostly all of the company, and that's because of their ongoing and scaled curiosity of how these tools can manifest themselves.
But what have you built actually? Have you built something?
Me?
Yeah.
Oh yeah.
Yeah, where you go?
His app is the number one in the charts at Nexar.
In your chart, internal charts.
Yeah.
Internal charts.
Not because he's the CEO, because actually I have to delay it. Okay.
I built an RFP scraper that went and looked at all of the publicly available RFPs that had been launched by any government agency and basically filtered them to the products and tools and services that we could provide in order to win them. So we've now built an automatic RFP responder where these RFPs present themselves, we respond to them, and it's very little human intervention. So it's, accelerated sales velocity and all.
Have you won any?
Not yet.
Too early. Who gets the sales commission if you win that? Who gets the sales commission? Is it the agent? Is it you?
It's the agent. It is a really interesting philosophy that we've started to adopt, which is, everyone talks about resources in terms of people, but resources are now being talked about in terms of agents. So you don't necessarily need to scale your human capital. You can scale your agent capital. So we have agents running across the entire company that are doing everything from product design to product deployment to creative to,
You have another example of someone who's non-technical at the company that's joined the agentic
Right? So I'll give you the stats on that, right?
Okay.
More non-developers are now on Cloud Code, both absolute and relative percentage, than developers. Okay?
Why aren't the developers on Cloud Code?
No, they are, okay, but the non-developers rushed into it,
Mm-hmm.
right? So you got 70% of all non-developers have built an app, a full app, in the last month on Nexar, multiple deployments, so over 70%. Okay.
Okay, give us more examples.
Okay. Apps. Our CFO built a budget prediction and analysis app so that he can do his job, right? Like with all the goodies that he wanted. We got a complex support kind of overhead, right? Like tier one, tier two, tier three, all this kind of stuff. We actually deal with hardware and in their inventory and stuff used to be done in Excel. Not anymore. Now you can identify ELP hit mishaps, changes, and stuff like that, and get it all sorted out, or at least be alert on it. And also lots of fun apps. We will build.
We have our sales team who all of them are actually building prototypes for customers on the call. So you can
Live building prototypes for customers on the call.
live building prototypes for customers. So instead of pitching a customer something that may be useful to them, that you can actually do a live collaboration, build the prototype, suggest to them, present it to them, and then go back and think through if it makes its way into your product lifecycle.
But
That's cool.
It's real, and
it's
Does it help close deals?
yeah, yeah.
Yeah, like for example, there's a big company that we're now working, very big company. We're now working on sort of a joint partnership, and they have their kind of sales team embedded everywhere, et cetera, et cetera. And when you on a call kind of show those people, they're eventually a channel, right? So they're gonna be as good as how you empower them.
Mm-hmm.
And when you go and show them on a call how they could kind of build an app that's custom for that customer or that customer, that's extremely powerful. That's exciting for them.
This is a really important point though on the power of unique data moats, is because the ability to build agentic tooling and applications that are all powered by the same underlying data moat create a level of flexibility for customers that is pretty unprecedented.
Explain that better.
So if I'm a Department of Transportation and I'm looking for a certain tool or product that predicts um, damage to roadways, right? I've now, as Nexar, built a product for them. I presented it to them. Great. They purchased it. We're managing the relationship. But let's say another Department of Transportation comes down the road and says, oh, that's great, but I also need stop signs. And I also need potholes. And I also need X, Y, and Z. We have the underlying data, but historically, because of limitations on agentic tooling, you had to spend product life cycles going and building those additional features. That's not an issue anymore, because now you can actually just
Roll the app on stop signs.
exactly.
That was actually a huge issue for us at Nexar over the years because you say, okay, we can't build 100 apps. We don't have the people for that. Right. So what are we going to do? We're going to build things that are common denominator, right? Potholes, stop signs, all the things that everyone need to. The problem with that and thing that we kind of suffer through is that those things, yeah, everyone need them, but no one is willing to commit suicide on them, right? Like no one is, oh, this will change my life forever, right? So it's a bit like, Amazon versus the traditional bookstores, right? Yeah, you can go and buy the best sellers, but what you really care about is something that you and 100 other people across the world interested in. Until Amazon came along, you couldn't get those books, right? Same thing here. We couldn't go and build 1,000 different apps for all the 1,000 different DOTs that each, in Columbus, Ohio, it's about black ice. In LA, it's about tents of homeless people, right? And trees that fall. That's like there's this long list, and we can't do it, but now we can, right? Or they can, which is even more powerful.
So what you're saying basically, if I put it in different words, is the software layer, the application layer has both become a commodity, and you're able to specialize it per customer much more. And the key is the data and the frameworks and which you think about this, and you can custom roll.
Yep. And
And
this is why before what I said before that Nexar is mining the future, the single most valuable asset class that doesn't exist today, which is, well, until now, which is real world data at scale. And the reason for that is because after you've been able to capture that really unique asset, you're able to create the software and application layer agentically that allows you to service your customers however you want.
And so everybody in the company is basically trained on Claude Code,
yeah,
and
more than that, everyone are encouraged and incentivized to use it. We actually did this quarter, we did a thing where, Cloud God gives you a certain amount of tokens,
yeah,
and then above that, we have to pay hard money,
yeah.
to get. So we said, okay, if you get to beyond that base layer and you start spending money, every dollar you spend is another dollar bonus to your salary.
You're bonusing people to rack up token bills on Claude Code.
Yes.
Yeah.
Correct.
Yeah. Crazy, right?
So the incentive is to create as much code as possible, whether it works or not.
Well,
Phase
Yeah.
one.
that's phase one. That's phase one.
Why do you have this bonus structure?
Because we have a bunch of ceremonies around that. That's actually the last thing that we introduced.
Oh,
But the reason for it is the following: the way Anthropic kind of budgeted your account is that if you're just walking linearly, just you and Cloud Code kind of building software, you won't max it out. The only way to max it out is if you switch from walking linearly to walking agentically. That is, you spin out a bunch of agents that walk in parallel, that walk on your behalf while you sleep, etc., etc. So the only way for you to actually spend money is if you were red pilled. If you took the pill, if you kind of move to agentic buildup, and so that's a signal for that, right? That's why we
Essentially replicate yourself.
yes.
How has it changed the way you operate the business? You come from a much more traditional operating background, at least Lyft, I think, is more traditional than certainly these guys at Nexar, or you guys at Nexar. How has it changed the way you operate the business?
Almost everything about the way we operate has changed. And I think the biggest takeaways were there's way less need for planning because everyone can move very fast, very quickly. There's way more need to empower agency and ownership. So when people own things end to end, they can build a lot quicker instead of having to manage interoperably across teams. So I think the biggest changes have just been the way that you manifest projects within organizations because they now don't pass across organizations hand to hand. They just kind of sit. So I think that's been the biggest adjustment. But I would also say coming from, a major publicly traded company to a startup, I think the exciting part about being where we are is the ability to just ask for forgiveness. Like just go build cool stuff. Everyone that works here understands what our mission is. They understand what our customers need. Go build cool shit, break stuff, and let's figure it out. And I think that's been probably the single biggest transformation that I've had from a leadership perspective is expecting, a level of failure that is only, um, that is only kind of presents itself when you've had enough success of continuing to build as quickly as you can.
Yeah, it's something hypey to that. Um, I think in the future humanity will celebrate kind of the 27th of November, which is the day that Anthropic announced Opus 4.5. And I would say the following is like every company that was launched before November 27th, 2025 has a debt that it needs to close or it risks its business, right? Because once we got software figured out, and that's basically the signal of Opus 4.5, now Communicate 2.5 came out, same thing. It's gonna spread like wildfire. Every aspect of the economics of building a tech company has materially changed. and you have to rethink it, right? Give you a small example. Typically, how do you define and design products? You have product managers define it, all kind of stuff. Designers design it. You do iteration until you're ready, and then you pass it on to developers, right? Today at Nexar, these designers are coming to the product after the fact, and they work not in Figma, they work in GitHub, right? They actually go and change the product that was built to meet the standards, the branding standards. They build agents that would go and basically, when developers develop, they will critique their work based on Nexar's design standards and change it on the fly. So the whole process went upside down. And this is a small example. There are lots of examples around that. The most important of which is an organization needs sort of, I can call the production immune system, basically a system that allows developers and non-developers to safely kind of deploy code, build it, make it happen without the CISO be getting a heart attack, without DevOps kind of, committing suicide, without kind of all these kind of problems.
That's what I was going to ask you because like I think many companies think about, oh my God, you get all this code and all these applications get completely out of control. I don't even know how to manage. It's going to become tech debt.
Yes.
In 3 years, that's just unmanageable. And
3 months.
in 3 months, it's unmanageable. And I'm not even sure exactly how to measure whether I'm being successful or not. It feels like
Yeah.
an unmanageable
Until you manage it.
until you.
So
How do you manage it? Like,
So that's
the
what
CFO is building a new budgeting tool. You got no idea if that's compliant or not compliant. He just built it.
So that's what we actually built, and that's even more important than all the agentic agents and there's what I said we call the production immune system, which is, and this is what Bruno, my co-founder, built. Think of it like this, right? The only way to deal with AI is AI. That's like the only way to deal with missile is missile.
Yeah.
So what we have in store at Nexar is a full-on kind of AI system that treats everything that anyone built with as a suspect, as faulty code, malicious code, kind of a bunch of AI slop, etc., until proven otherwise. And all of these agents, what they do is they review any kind of piece of code that was deployed, regardless of who did it. They reject it, they fix it, they do all this kind of stuff so that what ends up getting to production is nitty gritty, kind of very, very nice, very kind of working very well. And I think that's the future. If you think of organizations going either, oh, we'll let everyone do their thing, we can't stop it, and then, like you said, tech debt is being built, or no, we have to maintain our standard, and we'll put a person in to review everything, and then it's a bottleneck and nothing moves, and people are like, it took me 2 minutes at home to vibe code this cool app, and in my job, I cannot really do that. No, these two solutions are not the right way. The right way is to build a living system that understand the organization, understand its standards, and employ them in an agentic way.
And I think our deployment of this immune system has actually been what's accelerated us to be able to empower everyone to use the tooling. So a lot of the people that I talk to in the industry all reference the notion that, because of the DevOps compliance standards you have in the CISO, you have to make small incremental changes in order to actually deploy agentic tooling. And we kind of handled the hard part first, which was how do we make sure that anyone that builds anything meets the compliance standards that we have.
When you think about budgeting over the next 12 to 24 months, how has the agentification of Nexar changed your mind around budgeting or changed anything you think about budgeting?
So I think my hope is that as you think about planning and budgeting holistically, the pie just grows, which means you can grow revenue faster and you can use leverability on if you want to grow your OpEx faster. If you add more people, you could generate more code, or you can, maintain your human capital and grow agentic.
Have you seen any of this like on the fly agentic stuff, either in sales or that's actually produced a customer? Like,
Yeah.
you can point to.
Yeah, I'll give you one simple example. we built something called City Stream Intelligence um, back in December, not that long ago. And that's something that was exactly that unlock of taking our data and allowing you to do anything with that. Right. So that's the thing that when I talk about that partner that we just closed, that allows them to really go into that long tail of use cases. That's what happens.
So I'll tell a story for this. So we had our executive offsite,
December.
right, December, and we spent 2 hours arguing over this tool that we wanted to build, which was City Stream Intelligence. It was basically an information layer over our City Stream product that would allow you to derive interesting insights, whether for insurance purposes or for smart city purposes or whatever. And we literally argued for 2 hours. Iran sat there after lunch, came back and said, "Here's a prototype. It's done. Can we move on and stop talking about it?" And I'm not kidding. 2 weeks later, we produced one major distributor who's going to be distributing this product. We produced advanced discussions with two insurance companies that are using the layer of intelligence to predict risk. And we enhanced the product with one of our departments of transportation that's already using our City Stream product today. So it is like very real.
It was very. I think that the thing that blew my mind though was another story, which is Badass, our foundation, our world model. We had our first customer for Badass 3 weeks after we launched it. Right, like we couldn't believe it, but it needed to be real time for them to use it. When we launched it, every prediction took 2.5 seconds, 2,500 milliseconds. Right. Then we say, okay, we need to build a roadmap to get it to real time. Real time, let's say 40 milliseconds is a good number. And we were kind of planning that. And then only one of our researchers, the lead researcher for the project, comes after a couple of days. Okay, I'm done. Okay. We can deploy it. 3 days after that, it's deployed. And I'm pretty red pilled, but that was like crazy for me. And then when you deep dive into how it's done, it's like Cloud Code actually went in. We use an architecture built by Meta and actually went in layer by layer, analyzed the neural network. We found a bug in Meta's code. It turned it from CPU to GPU, all kinds of stuff that would have taken Ronnie or any capable researcher many weeks to figure out.
Wow.
Yeah.
It's a new world.
It's new world.
So, talk about your decision to take the data and actually build a world model, and speak about the world model.
Yeah. Well, let me talk about the decision first, and then I'll let Iran talk about the world model. So it was probably about 6 months ago now, where you know
You've been at the company now 14 months, 12 months?
14 months.
14 months,
Yep.
yeah.
Probably about 6 months ago, we had been through so many cycles with customers, and I mentioned before getting the market to meet us. And our argument had always been, you need real world data. You need to train on edge cases. Synthetic data is not going to cut it. And we were still running into this wall of either historical ways of buying data or defaulting into your typical development cycle of using synthetic data to simulate autonomy. So Iran and I looked at each other and said, why don't we just build our own model and prove for the market that you can actually get better autonomy results by training on real world data. We went and built it, and we ended up producing a state of the art world model that does collision and crash prediction that outperforms many ADAS solutions that are on the market today. And that was trained off of a very small corpus of our data. So it ended up creating so much virality that we now have customers that are using it in production, and we are building an entire family of models that are surrounding the same methodology. And our hope and our conviction is that we'll be able to deploy this at scale, and help companies reach their autonomous goals way faster.
You deployed the model on Grand Theft Auto,
Yeah.
right? I think
Yeah.
that was a
Yeah, that was one of the fun ones. Because if you think about it, Grand Theft Auto is a great environment to test this kind of thing, right? Like you have all kinds of things coming at you. And also, it's super legit to crash into things there. So you can actually test a model that's supposed to.
Yeah, but is it real? Is it real?
So the question is, the question is it real in the sense of, what we see? No. But is it a good test case for such a model? Yes, exactly, because it's not real. Because we train it on real world data, right? So obviously, if we put a real world video on it, it will work well. But that's easy to test. We have millions of videos, we can test it. Where it's starting to get interesting is when you sort of stretch it out of the ODD you trained on. And GTA Grand Theft Auto is one way of stretching it. Will it work on it on a game? Well, apparently yes. It turns out yes. And then we're like, oh, someone did a video to ASCII transformer where you can take a video and it turns it into ASCII video, ASCII imagery. Will it work on that? That's like, very low resolution ASCII kind of stuff. Well, it turns out it works on that as well. And then kind of the floodgates opened up because we started testing it on all kinds of crazy stuff, right? Like with spaceships and dragons and chariots in the woods and all kind of stuff. And it turns out it generalized extremely well for all things that could happen.
So this point is significant, and it's because where we started as a company was pushing the envelope that real world data could be used to create a model that could help accelerate autonomous vehicles. And now where we're going is this model can actually manifest itself in all physical AI applications that need to understand physics. So industrial applications, agricultural applications, defense applications, really anything that has physical movement that is in anticipation of a collision, risk prediction, crash prediction, this model can understand and help train.
And that's exactly the definition of a world model. It actually understands the world. It doesn't understand, what to predict in very confined situation, but actually understand the underlying world behind it.
And why is it able to generalize this from road data?
So that's a fascinating thing that we're still, I think, thinking of. Uh, First of all, we should give credit where credit is due. Our model is based on an architecture called VJEPA that was pioneered at Meta, Jan LeCun's work, and that's an architecture that does something very interesting. It works in what's called latent space.
It's like latent space?
Latent space.
Latent
So
space.
thank you for
Sure.
correcting my English.
Just making sure.
Yeah. So
I want to make sure I understood it.
yes.
Yeah.
Latent space means that it doesn't work at the pixel level.
Yeah.
It transforms the pixel, how AI works, transform the pixel into some representation space, and then it does its thing, and then it transforms it back to whatever, text, pixels, whatever it is. The thing about Dapper is that it works at a latent space, right? It comes to the conclusions that are void of any details that the pixel hold. It doesn't care about that. It generalizes into. So that's point number one. JEPA is a great place to start for world model. But point number two, I think that we're just realizing is if you want to collect lots of data to train a model on physics, what would you do? Would you go and put cameras on rockets? Great, but that's a very thin sliver. Would you go and put them on in factories? Okay, but that's a very thin sliver as well. It turns out that, and this is not planned by us. Like 10 years ago, I didn't see all that future ahead. That collecting real world data from the public space, from the physical world using dashcam is probably one of the most efficient vectors in collecting data for physics in general because of those flying cars and because of all the things that could happen on the road. And it just works really well. It generalizes really well.
What is the craziest thing that you can imagine to yourself right now that over the coming years, these models across all these areas of physics will enable?
I don't know the craziest. The thing I am most hopeful is an uncrushable car.
To explain, what does that have to do with an uncrushable car?
Well, today it's still 1.5 million people die every year from car accidents.
Right.
And 99.7% of all miles, even in the US, are not autonomous miles.
Right.
Right. And we are, as humans, we're really bad at making decisions in those fractions of seconds that where something really bad is happening. Right. So I think the really cool thing that we could do with Badass is have it engage at the right moment and get you out of a dangerous situation safely.
So not uncrushable cars. It's more like, hey, let me get you out of here so that you don't get crushed.
Yes,
Hey,
exactly.
what's another crazy application? That feels like what we thought of doing at the beginning.
Yeah.
But what's
The-
the crazy thing that the kind of generalization of the physics model?
So when you think about the generalization of this model, a lot of it is because of physics, right? Now, when you think about the future of AI applications, physical AI applications, where it's a autonomous vehicle, a robot, or whatever it might be, and they're coexisting with humanity, there is this notion that you're going to get to a certain place where making these objects more human is actually core and essential to them effectively coexisting.
Understand.
So what I mean by that is you can make a humanoid robot, you know, manage against collision and crash or prevent collision and crash against another human, but it will be very difficult to make it coexist in like an emotional and humanity type of scenario. However, if you've been able to solve the physics problem and you can generalize these applications into a place where you can now start ingesting human data, you actually create a far more real type of feeling in an application. So when I think about the applying the badass or family of Nexar models to other applications, I think about it in terms of how it ends up manifesting itself in humanoid robots or in actual flying cars, or not the flying cars that you would want to have, um, in ways that are just not even foreseen yet. Because right now everybody trains these on like static real world data that doesn't really have any human feel towards it.
The real world is 3D. Dash cams are 2D. Like, how does this actually translate into physics?
that actually AI turned out solves really well, moving from like a 2D video into 4D actually, if you
4D. What's the fourth dimension?
time,
Time.
right? Like because it changes over time.
Yeah.
So that's something that turned out AI can do really well. If
When you think about time, you just reminded me now. What's a video we saw 9 years ago and we see today and looks vastly different?
huh,
Feels like the buildings in Manhattan have changed a little bit, but what else, right?
it's actually fascinating how things stay constant, right?
But you think the world's going to change a lot in the next 9 years?
Yeah.
Even though over the last 9 years it looked the same.
Yeah, but because we're really bad at understanding exponents, right? And this is this kind of inflection point where things will get compounded and get crazier and crazier from here on out.
Last two questions. Who named the model Badass?
I'll take credit for that one. No. Well, we played around with a lot of names, but actually I remember a bunch of people telling me that it was really stupid to name it that, and I was like, why? And like, because it's gonna sound way too edgy and a little too not serious. I'm like, yeah, but
Because it's missing an S.
it's missing an S, so it's not technically.
What else could it be? What else could it be? It's the most natural name
Yeah.
for originally an ADAS model.
Yeah.
Really, I don't understand how no other company took it on before us.
Yeah. Beyond ADAS, it's the most.
So you trademark it?
Of course we
Yeah, of course.
Yeah, of course you did.
Yeah.
Without the S.
Yeah, without the S. One S.
Last question, what's been the hardest part about this transition for you as a founder?
For me, I think it's about worrying about the people. Right at the end of the day, I'm like, these people have gone with me for a long time. Some of them 8 years, 9 years even, and I'm putting them through this transition. Forget about my transition; they're gonna be kind of they're along for the ride without having a lot to say about it. And so, I was really worried about them really fitting well with it and getting the right treatment, knowing that they matter, even though the CEO is now in New York and not in Tel Aviv. And that's why, by the way, Zach is here in Tel Aviv now.
What's been the hardest thing for you about managing an organization whose headquarters was previously in Israel and now in New York?
Um, the hardest part certainly has been not being able to be here physically all the time. I think that, I come from places and I strongly believe in the in work or in the in office culture. I don't subscribe to the whole I can be productive everywhere. I agree you can be productive everywhere, but there are magic moments that happen in the office that you cannot replicate virtually. And I think that being in New York, where, by the way, even though we're headquartered in New York, we have the smallest employee base in New York. The largest is still in Tel Aviv, and the second is in Porto. So there is still a need for me to figure out how to create the physical presence with the team as much as I can so we can create those magical moments.
World model, Tel Aviv, Porto, New York,
There you go.
and other points around the world.
Yeah.
Zach, Eran, thank you for coming on to Invested. If you enjoyed this episode of Invested, please rate us 5 stars on Apple Podcasts, Spotify, subscribe on YouTube, and do those other great things. And if you want to follow Zach or Eran, what is your
Eran Shir.
Eran Shir on Twitter? That's at ERANSHIR. And Zach posts much more on LinkedIn. So find him there, ZACHGREENBERGER.
There you go.
I got to go the extra ER behind my own name in order to get there. Thanks for doing this.
Thanks, man.